Hello all, welcome to the Counting Well exam prep live session. We know that exams are around the corner and it's time to push yourself to study hard and wish to score good. If you study hard, then you will make a great start. So forget your fear when your paper is near and give your best shot. So we are here to help you revise your concepts before it's too late. For this, stay tuned to the session and build up the confidence to face your exams. In this session, I will take you through the chapter Data Handling from Class 8. So, data handling is an important concept that makes you sure about the uprightness of the research data. We have information in the form of a numerical figure, no matter which field we take. So, every value of this type is known as an observation, and usually the set of all the observation is nothing but the data. So different data management methods are used to handle, which will be discussed in this chapter. And also, if you go to higher classes. So when do we use data? If you want to analyze the height of competitors in an athlete's meet, we have data of the heights of the competitors. If the number of passengers boarding trains, for example, say from 7 a.m. to 7 p.m. at a station, then you need to analyze and interpret this data. So let us see how we represent this data and how we organize and how we interpret it. So let us see first of all what is frequency. So frequency of a data is nothing but the number of times the data or observation occurs in a data set. So observation is nothing but the members or the elements of a data set. So the number of times that observation occurs in that set is nothing but its frequency. For example, if I have a set of number 1, 2, 3, 4, 5 and 6 and then 5, then the number of times the observation 5 occurs in the data set is 2. Let us see what is a group frequency distribution table. So it is nothing but a tabular arrangement of data which shows the frequencies of various observations or class intervals of given data. Okay. So group frequency distribution is first of all nothing but a tabular arrangement of the data. It shows two columns, frequencies of the observations. Okay. And it should be of various observations, or we can write the class intervals of given data along with the frequency. Let us see some important terms included in this chapter, which is class interval. Each group, for example, 30 to 40, 40 to 50 is called class interval. So if I have a set of observation lying between the values or the numbers 30 and 50, so in that case, I'll have two class intervals, 30 to 40 and 40 to 50. Now let us see upper class limit and lower class limit. So whenever I have a class interval, I have a lower class limit. For example, 30 to 40 is one class interval where 30 will be the lower class limit and 40 will be the upper class limit. Okay. And what will be the size of this class interval? It will be nothing but the difference of the upper class limit and the lower class limit. So this will be the size of the class interval. For example, here we have class interval 30 to 40. So the size will be 40 minus 30, which is 10. So the size of this class interval is 10. Let us see how to draw a frequency distribution table. For that, first we have to identify the class interval. So we need class intervals when the data set is a large set. Okay, say for example, there are 15 or 20 observations in the data set, then you need to categorize them like by making class intervals, and then you have to make a table with class interval and frequency. Okay. Then we have to record the frequency of observations falling in each group. Okay. Now let us see histogram. Histogram is nothing but representation of grouped data in the form of rectangles or bars of uniform width. Okay. So whenever we group data, we can represent them in the form of rectangles, as you can see here. So rectangles are nothing but bars of uniform width or uniform class interval. So the class interval you are taking should have the same size or the same width. That's why we'll get the rectangles or bars also of the same width. And a histogram has a title, scale, height of the bar representing the frequency of particular class interval. Then we have a jagged line or broken line which is being used along horizontal line to indicate that we are not showing the numbers between 0 to 100. So let us carefully see this and understand. So here goes the title, as I told. It is the weekly pocket money of 20 students. So the number of students. So here you can see 4, 5, 7, 3. Correct? So we have a data of how many students? 20 students. And here 1 unit is equals to 1 student. This is nothing but the scale of the histogram. So here you can see on y-axis we have 0, 1, 2, 3. So this 1 unit shows number of students as 1. Okay. So when you mark the bar till here, it means there are 4 students in class interval 100 to 200. Okay. And on x-axis we have marks. On y-axis we have number of students. So height of the bar will give the frequency. So there are 4 students having marks 100 to 200. Here you can see a jagged line. Okay. This shows we do not have any observations between 0 to 100. That's why we have broken this line and then we have started the mark as 100, 200, 300 up to 500. Let us see how to draw a histogram. We have to follow these steps. First, you have to mark a reference point O on the graph paper, and then from O draw a vertical line which will be your vertical y-axis and horizontal line which will be your x-axis. Then you have to mark class intervals on the horizontal line and suitable scale for the vertical line. So always remember class intervals on horizontal line and your frequencies on vertical line. You have to determine the bar or the height of the each of the bars from the given data and then draw the bar. So the height of the bar will be the representing the frequency of the data. Now let us see one more representation of data which will be in the form of a circle. So pie chart is nothing but it is a graph that represents the given data in a circle. For example, here we have a pie chart and there are 5 slices. So here you can see the 5 slices. Okay, this slice 1, 2, 3, 4, 5. There are 5 colors shown here for this pie chart. We can see the slices are nothing but the sectors of the components. Okay. And the circle is divided into sectors corresponding to the fraction of each data component on the whole. So if we take the circle as a whole and fraction of the data represented by the sectors of the circle, then it is a nothing but a pie chart. So here the pie chart represents the number of hours a child spends on each activity in an entire day. For example, here we can see the child spends 40% of his hours of 24 hours. Okay, 40% of 24 hours or of a day for sleeping. Then he spends 12% in his school, spends 9% for play, spends 14% for homework, and for other activities he spends 25%. So the central angle or the center of each circle is considered as the central angle and its measure is 360 degree. So this is very well known to all of you that this is the central angle and it is measuring 360 degree. Each sector will be drawn as an angle from the center. So you can see the sector for homework is this much angle, sector for school is this much angle, and sector for sleep is this much. So the sum of the central angles will be 360, and generally we use pie charts to show data in the form of percentages, correct? So we are using here percentage. Next, while drawing a pie chart, okay, as I said, we are using percentage. So how to calculate this? First, we need to know the central angle of the component, and we have to calculate it for all the components. So it will be frequency of the component divided by sum of all the frequencies multiplied by 360. Then we have to draw a circle of any convenient radius. Don't take the radius too small or too large. It should be within the size of your paper. So you have to make the sectors for all the components. And when you have to express or when the values of the components are expressed in the form of percentage, then you have to calculate by using this result. Frequency of the component upon 100 into 360 degree. So step 2, you have to draw a circle of any convenient radius and then you have to mark the sectors for all the components and represent the components using percentage. Now let us see what is probability. Under the concept probability, first we have random experiment. It is nothing but an experiment whose outcome cannot be predicted exactly in advance. So for example, you can take any event. Event means here the event is getting a head or tail. And tossing a coin is nothing but a random experiment. Because after we toss a coin, it is not up to us whether head will come or tail will come. So we cannot predict the outcome. So you can have a number of random experiments and one of the experiment is given here, which is tossing a coin. Now let us see what are equally likely outcome. They are the outcomes that have an equal or same chance of occurrence. So when you toss a coin, the chance of getting head is 50%, whereas chance of getting a tail is 50%. So it is like both are equally likely to occur. Either head will occur or tail will occur. So if say for 100 tosses, there will be approximate 50 times head and 50 times tails. Like that we can say. What is probability? Probability is nothing but possibility of something happening or not happening. So it will probably rain or it won't. So that is the case we are using probability. It is nothing but certainty or possibility of something is going to happen or it is not going to happen. What are the properties of probability? The first important one is it should lie between 0 and 1. So the value of probability cannot go beyond 1. So we cannot say probability of any event is 2 or it is 100% or like that. So we cannot calculate it in terms of percentage usually. In this chapter, we are calculating its value between 0 and 1. Probability of impossible events is 0. Okay, impossible events are events that are compulsorily not possible to happen. And the probability of certain event is 1. Okay. Say for example, I have a circular disc and I have written H on both sides of the disc. So the probability of getting a head once I toss that circular disc is 1, because no matter how I toss, there is only one outcome that I'll get, which is H. That's why the probability of getting a H for the given circular disc is 1. Whereas the impossible event is getting a T on the circular disc, because I don't have T on either side of the disc. I have H on both the sides of the disc. So in this case, probability of getting T is 0. Let us see formula for probability. It is nothing but total number of favorable outcomes divided by total number of possible outcomes. Let us see some tricks for the exam. This is the trick to draw a grouped frequency distribution table. So after drawing the table, you have to add all the frequencies and check whether the sum of the frequencies is same as the number of observations. So as you know, frequency of any observation is number of times that observation occurs in the data set. So here we have a data set of how many plants? 26 plants. And the data is of the length in centimeter. So the data is about the length of plants in centimeter. So the number of observations will be 26, because it is data for 26 plants. And what are the frequencies we have? 4, 8, 4, 9. Okay. So here the frequency distribution table, you can see it is a tabular arrangement of the class intervals and the frequencies. So here we have two columns. One is for length of plants and one is for the number of plants having particular length. So particular length means here we have class intervals. How do we have find these class intervals? We have to find the least length among the observations of the data set. Then we have find the greatest length. So find the least length and find the greatest length, and then we decide the class intervals. So here we have 4 class intervals: 200 to 275, then 275 to 350, 350 to 425, 425 to 500. Here you can see the class interval are continuous, means it starts from 200 ends to 275. The next class interval will start from 275 only, means the limits you can see here, this is lower class limit, this is higher class limit. Okay, so the higher class limit of the first class interval and the lower class limit of the second class interval both are same. So if we have any observation as 275, will we include that observation here or here? Will include in this class interval, which is 275 to 350. So this should not be taken as in confusion. Okay, then number of plants having lengths 200 to 275 is 4. Means there are 4 observations between the lengths 200 to 275 centimeters. So here you can see first observation is 234. 234 lies between 200 to 275. That's why we have here one observation. Next, you have to check for 430. 430 lies in the class interval, which is 425 to 500. So here we have one observation. Similarly, we'll complete all the 26 observations, and then we have these frequencies. So there will be 4 plants having lengths lying between 200 to 275 and so on. Now let us see the tips to read a histogram. You have to check the scale of the graph. Means you have to check how much one unit represents, and then based on the scale you have to calculate the actual frequency. For example, if you have 1 unit equals to 1 student and the bar represents 5 units, so it represents 5 students. If 1 unit is equal to 5 students and the height of the bar is 5, then the actual frequency will be 5 into 5, which will be 25 students. Let us see some tricks to draw a histogram. First of all, you have to use a sharp and dark pencil while drawing a bar graph. Okay, so that we can clearly see the frequency marked or the height of the bar, because it is very important. Next, you have to choose a scale such that the height of the bar fits in the graph paper. So the height of the bar should not go beyond the graph paper or outside the graph paper. That's why you have to cleverly choose the scale. Scale means you can see here they have chosen 1 unit equals to 100 students. So here you can see the markings are 100, 200, 300, means 1 unit is equals to 100 students. And we have frequencies like 350, 550, 750 and so on. So choosing like 50, 100, 150 and so on, the graph, the y-axis will go outside your graph paper. That's why it is very important to choose the scale properly. The height of the bars should match the frequency of the category. So if the frequency for the class interval 5 to 10 is 350, then you have to correctly mark 350 here. Okay, you have to correctly mark 350 here. And if the frequency for the class 10 to 15 is 550, you have to clearly mark it here. And here you can see for 15 to 20, the frequency is 750. So you have to clearly mark, you have to take the height of the bar till 750. Okay. And one more important thing is there shouldn't be any graph gap between the bars. So here you can see it is continuous, 5 to 10, 10 to 15, 15 to 20, 20 to 25. That's why we are taking the continuous class intervals, means the higher limit of the first class will be the lower class limit of the second class. Also, do not forget to name the horizontal line and vertical line. So here horizontal line represents the marks and vertical line represents the number of students. Also, you have to name and graph. You have to name the graph or you have to give title of the graph and also mention the scale. So here the scale is 1 unit equals 100 students. You have to mention in the graph. And the title of the graph is important. So it is nothing but graph of marks scored by students in the maths test. Now let us see tips to draw a pie chart. To draw a pie chart, the first step is to calculate the central angles of all the components. So what are the components? For example, here you can see a distribution or the data of types of animals along with their frequency or the number of animals. So there are 400 land animals, 325 birds, 125 water animals, and 100 reptiles in a zoological park. So if you add these frequencies, you will get the resulting sum as 1000. So there are 1000 creatures in a biological park shown here. So what are the components here? The components are land animals, birds, water animals, and reptiles. So you have to calculate central angle for all of these components. Then after calculating the central angle, you have to check if the sum of all the central angles add up to 360. So once you have obtained the central angle, you have to add this. Okay, here the addition comes to be 320, which is not 360. That's why you have to recheck the calculation for the angles. Let us see what are some common mistakes students can do. So where does the observation 30 belong to? Whether it belongs to the class interval 20 to 30 or it belongs to 30 to 40. So as I told you, an observation 30 will not fall under the class interval 20 to 30. You have to take the next class which starts from 30. Okay. So 30 belongs to 30 to 40 and not to 20 to 30. If you have a reading or observation 40 and you have next class interval 40 to 50. So whether it should belong to 30 to 40 or 40 to 50. Yes, it should belong to 40 to 50. I hope this is clear now. Significance of broken line in histogram. Here you can see after 0, it starts from 40 and there is no broken line. But here you can see the scale is 1 unit, correct? 1 unit equals to 1 child. The weight starts from 40, 45, 50, 55, 60, 65. And the size of the bars are uniform. So after 5, we are denoting 5 units. So 40, after 40 we have 45, then after 45 we have 50. So the size of the class intervals are same. So it is not correct to show 40 directly after 0. You have to make it a broken structure, okay, a broken line. We are not showing the data between 0 to 40 kg, and so there should be a broken line along the horizontal line. Also, there should not be any gap between the bars of a histogram. So this one is correct, this one is not correct. Okay, the child or the student has made bars with taking 25 as the central point of that bar. So this is not the correct way to do. While drawing a pie chart, the first step, as I told you, is to calculate the central angles for all the components. And without calculating the central angle, it is not possible at all to represent the data in a pie chart. Because in a pie chart, we are representing the data in a circle, and a circle can be made only using 360-degree angle from the central point. So the table shows the expenditure of a person. The person expends 40% on food, 25% on entertainment, 20% on other expenditure, and 15% he has savings. Now, if you want to represent the data in a pie chart, you have to convert it into central angles from percentages. So you have to divide the percent value by 100. So as it is percent, you have 40%, means 40 per 100 multiplied by 360. So we are taking 40% of 360. Then we are taking 25% of 360. Then we have 20% of 360 and 15% of 360. So we have the central angles for food, entertainment, other expenditure and savings as 144 degree, 90 degree, 72 degree and 54 degree respectively. You can check by adding these angles, you will get the sum as 360 degree. So in this way, you can draw a circle. Okay. So your data will be a circle. It should be represented by a circle called pie chart. Now let us see some exam tips for this chapter. First is you have to practice a variety of questions from NCERT books. You have to note down all the definitions. Avoid calculation mistakes. I hope this session was helpful, and if you want to quickly revise the concepts, practice some extra questions, and also take a quick test, then exam prep counting bell prep kit is here, and it lets you quickly glance through the major concepts of your chapter. You can also glance through the solved examples, practice questions, and chapter assessments. You will also understand the tips and tricks involved, the common errors that you make, etc. Over 75,000 students trust counting well for their maths learning, and even without the exam prep kit, they can learn every day on the app by diving deep into every chapter. You can download the app from the App Store or Play Store. Also, stay connected to our channel Counting Well and learn more tricks and tips and ways to avoid the common mistakes. We will be revising the chapters, comparing quantities, perimeter, and area from class 7 in our next live session tomorrow, that is on 23rd February at 6:30 p.m. Well, see you in the next session. Until then, keep learning, keep growing. Thank you.